We're going to show you how to solve 7 of the hardest math SAT questions using Desmos. These concepts are frequently tested by College Board, and they're really likely to show up on your next test. So learn these and so you can attack your next test questions.
Yeah, and for every single one of these questions, we're gonna go them step by step and show you how we got the solution so you can understand. And if you know all these question types, you're gonna be fully set on the SAT for the math.
Yeah, and if you want to just like pause the video right before we solve it, try to do it yourself and then see how we did it, you should do that too. In the xy plane, a circle has center C with coordinates hk. Points A and B lie on the circle. Point A has coordinates h plus 1, k plus root 102, and the angle ACB is a right angle. What is the length of B? Okay, this seems like a lot right off the bat, so let's just draw it in piece by piece. So let's draw a circle, center C, with coordinates hk. So since we have hk in both these, we can just like assume hk is 0, 0, because it's not really gonna matter. You can assume it's anything really, but 0, 0 is easy. So then point A has h plus 1, so 0 plus 1, 0 plus root 102, so it goes over 1, up root 102. Okay, so this point is gonna be 1 root 102. And then it says this is A, this is C. Angle ACB is a right angle, so AC, something like that, right angle B. And now what we can do, since C to A and C to A and C to B are the same, they're equal because they're both radii of the circle. So we can find, if we find one, we can find the other, and we can find length of A using Pythagorean theorem. So we know it goes over 1, so this length is 1, goes up root 102, so this length is root 102, and then we can take that into Desmos. 1 squared plus root 102 squared equals x squared. So 10.14, you might be thinking like, what? So what we can do is we can just say it's 103, but we know that has to be squared, so we can just say that's square root 103. So that's the same answer. So we know that the length of this is square root 103. Length of this is square root 103. And since this is we're trying to find the length of AB, this is a right triangle, we can use Pythagorean theorem again to find the length of AB. So we can say root 103 squared plus root 103 squared is 206. So we know that that has to be squared because a squared plus b squared equals c squared. This is c right here, so we need to square it. Or this is c squared, sorry. So we need to square root it. So square root 206, that would just be your answer. So we're going to go with A.
For this question, it says the speed of a vehicle is increasing at a rate of 7.3 meters per second squared. What is this rate in miles per minute squared, rounded to the nearest tenth? So for this question, we're using a method called dimensional analysis. So to start, we're going to make a table here. And then we can start off with our initial value, which is 7.3 meters per second squared. So we can put that up here, 7.3 meters. And on the bottom, it would be seconds squared. And then we want to cancel out the meters, so we're gonna put in the meters on the bottom, and we want to put something that's converted to that, which is miles, and then it gives us that conversion, which is 1 mile for every 1609 meters. So if we put 1609 meters here, and then we put 1 mile here, that means the meters are going to be canceled out. And then next, we want to cancel out the second squared, and we know that and we want to get minutes, so for 1 minute squared, and on top of that, how many seconds squared is there in a minute squared. We know that there's 60 seconds in 1 minute, so we put 60 seconds, and then we can square the whole thing. So overall, 60 seconds squared would be 3,600 seconds. So that will end up being 600 seconds squared. Okay, and that means that the seconds squared are going to be canceled out, and we're left with miles over minutes squared. And now to finish, we want to multiply the top and divide by the bottom. So it'd be 7.3 times 1 times 3,600 divided by 1,609 divided by 1. Then we get 16.3, which is the answer.
So it says, for each real number r, which of the following points lies on the graph of each equation in the xy plane? So when I see equations just in two variables, I'm just going to immediately put in the Desmos. So 7x plus 6y equals 5. 28x plus 24y equals 20. And you might notice that these equations, or these lines are exactly the same. So now that we know that, we can just plug in our points. So r, comma, negative 6 over 7r, plus 5/7. And we can see Desmos obviously doesn't know what r is, so we can add a slider for it. And it's a real number, so we can just say, let's just say it's like 3 for now. So we can see, we can just drag it. It's on the line here, it's near it, but it's not on the line for every real number. So we know it's not this one. So we can plug in b, r, comma, 7 over 6 r. Whoa. Seven over 6r, or 7r over 6, sorry. Plus 5/6. And then we can see we can drag the slider. It's on the line there, but it's not on the line for every point. So we know it's not this one. Next one, we have r over, r over 4 plus 5, comma, negative r over 4 plus 20. Oh my goodness. What? Okay, so we can see again, this point is not on the line for every value for each real number r. So let's plug in our last one. Negative 6 over 7r. Oh my gosh. 6r over 7. Plus 5/7, comma, r. And we can see for this one, looks promising. For every real number r, it is on the line. So our answer is just going to be D.
So first, this question gives us a table which gives us the coordinates of 2 points on a line in the xy plane. The y-intercept of the line is k minus 5 comma b, where k and b are constants. What is the value of b? So we see this table, and we can just put that into Desmos, just like how it comes. And then we don't know what k is, so we can just put that for there for now. But if we look back to the y-intercept, it tells us it is k minus 5 comma b. And we know that when it says y-intercept, that means the x value has to be 0. So for the x value to be 0, that means k has to be 5. So 5 minus 5 is 0. So if k is 5, we can plug that in here. And then that makes a complete table. And then we can click on add regression, which is a line. And then we can see where that intersects the y-axis, and we get 33. And then it asks us what the value of b is, and that would be 33. So some people who look at this question might be confused because it's tricky wording, and there's a lot of different like words and values. So the question asks, each side of a 30-sided polygon has one of three lengths. The number of sides with length 8 centimeters is 5 times the number of sides n with length 3 centimeters. There are 6 sides with length 4 centimeters. Which equation must be true for the value of n? So it's asking for n, which is just the amount of sides. So in reality, we don't even need to look at the length. So we can just get rid of the length completely and not worry about that. And we know that there's 30 sides in total. And here it tells us the length with 8 centimeters is 5 times with this other length. So it means there's n, which represents the amount of sides that have 3 centimeters, and then we have 8 centimeters sides, which is 5 times the number. So we have 5n. So that's already a certain number of sides, and that tells us there's 6 sides. So we just put that together, that should be equal to 30. So this should be the equation to solve for n. Then we just combine these two numbers right here, which would be 6n plus 6 equals 30. And then that's B for you right there. So this question is not very hard in reality. So you just gotta look deeper and make sure you're not looking, you're not getting confused in the question.
So the question says, in the given equation, s and r are constants, and s is greater than 0. If the equation has infinitely many solutions, what's the value of s? So with these two expressions here, you can put it in Desmos and set them equal to each other. So we're going to replace x with x1, so Desmos knows to use a regression. And we're just going to type it in exactly how it is. Minus s over 13. And then instead of using an equal sign, we're actually going to use a tilde. That's how Desmos knows it's a regression as well. And then we're going to continue typing it in. Oh gosh. And just like that. But here it says x1 equals 1, which means it can only equal 1. So these aren't correct values. So what we're going to do to fix that is we're going to type below x1 equals random set of 10 numbers or whatever you want, 100 numbers, however many numbers. But s always stays the same. S is 403, and that's what the question is asking for. So that's going to be your answer.
So some people, when they see this question, they might be confused because they see variables and like constants, and then they also see functions and functions. But in reality, it's really easy, and I'm going to show you how to do it. So the question asks, function f is defined by f of x equals negative a to the power of x plus b, where a and b are constants. In the xy plane, the graph y equals f of x minus 12 has a y-intercept at 0, negative 75 over 7. The product of a and b is 320 over 7. What is the value of a? So to solve this, we're going to look at this function right here, and then we see that it's also in this y equation. So we can plug whatever the function equals into the y equation. So let's do that and show it to you on Desmos here. So it should be negative a to the power of x plus b, and keep it 12. And then we see that the y-intercept is at 0, negative 25 over 7. So we can plug those points in for the x and y values. So it would be negative a to the power of 0, and the y would be negative 75 over 7. And we know that anything raised to the power of 0 is 1. So it would be that a term will be 1 now. And we'll keep the negative, so it would be negative 1. B was 12. So now we can solve for b, so we add everything to the other side. So it would be negative 75 over 7 plus 1 plus 12, and that will equal b. And then we want a fraction for this, so we can click this button right here. We get 16 over 7. And we know that the product of a and b is 320 over 7, and we're looking for the value of a. So we have b, so we can plug in that for b, and then we get 16 sevenths times a equals 320 over 7. And then we would want to divide each side by 16 over 7. 320 over 7, all divided by 16 over 7. And we get 20. And the question is asking for a, so that means the answer is 20.
So the question says, for the function f of cx equals x minus 8 for all values of x where c is a positive constant. If f of 2 equals 35, what's the value of c? Okay, we're looking for the value of c, and we have this relationship right here. So what we can do is we can set the 2 equal to cx, and then we can set 35 equal to x minus 8. So if we know that c of x, or cx equals 2, and then x minus 8 equals 35, then using this we can see that x equals 43. And then we can just plug this 43 right into this expression. So 43c equals 2. And then dividing by 43, we can see that c equals 2 over 43. And 2 over 43 is our answer.